Good morning, guys. So what we started the other day for discrete math, we started analyzing different types of polygons, right? Depends on how many sides a shape has, right? So a polygon that has 3 sides, we call it a triangle. A polygon with 4 sides, a quadrilateral, right? And we learned the only one that's not a polygon is a circle, because in order for a figure to be a polygon, it needs sides. So a circle is not a polygon, right? We analyze polygons and then equiangular, equilateral, regular, all of those terms, right? Today we're going to be going into symmetry. And we're going to be going into a certain type of symmetry called reflectional symmetry. And I have a feeling that you guys are actually going to do well with this, just because I want to say that this is something that you guys have already done in the past in elementary school, right? So, excuse me. So with symmetry, when we're looking at an object, right, and we're trying to see if that object has symmetry, what symmetry means is that an object, whatever you do to it, whether you actually cut it in half, whether you turn it, whatever you do to a figure, if both sides are going to be the same, or if you've cut it in half and both sides are the same, or if you've turned it and it's exactly the same, that refers to having symmetry, right? And the best way I can explain it is what you guys would call a line of symmetry, right? So what reflectional symmetry is what we're going to work on today. There's 2 types. There's reflectional symmetry, and then there's rotational symmetry. Reflectional symmetry literally means you flip something from one side to the other, right? Rotational symmetry means that you turn it. So what we're going to learn today, reflectional symmetry, just means whenever you flip something from one side to the other, top to the bottom, left to right, whenever you flip it, like the left side here would be exactly the same as the right side, or the top would be exactly the same as the bottom. If whenever you reflect it, it's exactly the same, that's referred to having symmetry, right? And what you guys know it as is something called the line of symmetry. Now let me show you what I mean. Let's say that we have, and I'm going to try to the best of my ability. Let's say that we have a face, right? I'm trying to draw perfect for a reason, right? We have a smiley face. And again, I'm trying to draw it the best that I can. This side's a little bit bigger, but you guys get the point. If we're looking at this, what reflectional symmetry means is if I were to split this and flip it from one side to the other, if both sides are the same, it has symmetry, right? If you can't, it doesn't have symmetry, right? And what you guys know it as a line of symmetry. So looking at this smiley face, is there a way for us to actually split this for both sides to be the same? Yes. If we were to take this, right, and split it straight down the middle, if we were to split it that way, right, and I were to now flip it from the left side to the right side, we know that both sides are exactly the same, right? So when those 2 sides are exactly the same, we know that this is a line of symmetry, right? That's a line of symmetry. Because what a line of symmetry does is it literally splits something exactly the same way on both sides, right? So that would be a line of symmetry. So when we're looking at this, we know that it has one line of symmetry, right? Smiley face, because the left side and the right side, both exactly the same. So if I were to close it this way, both sides would be the same. That's why it's a line of symmetry, right? And it only has one line of symmetry for one reason. If I were to actually, let's say that I, instead of splitting it down the middle, right? Let's say that I were to try to draw a line of symmetry. Let's say I were to try to draw a line of symmetry going across, right? We know that this would not be a line of symmetry for one reason. If we were to flip the top now to the bottom, we have 2 eyes here, we have a mouth there, it's different, right? If you were to flip it down, the eyes are up here, there's no eyes down here, the bottom is not the same as the top. That's why this would not be a line of symmetry. A line of symmetry has to cut it perfectly in half, right? That. So when we saw this smiley face, we know that this smiley face only had one line of symmetry, right? And again, let's start looking at examples, right? Let's say that we have a triangle like this, right? And I'm going to tell you that it's an isosceles triangle, so just those 2 sides are the same. If we wanted to see how many lines of symmetry this has, we would see the only line of symmetry that this triangle has, it's just down the middle, right? And it's just down the middle. It has one line of symmetry, one line of symmetry, down the middle, the left side is exactly the same as the right side, right? Can't split it any other way. You can't split it across, you can't split it on diagonal, because not everything is the same, right? So this triangle would have one line of symmetry. And all reflectional symmetry is because you're literally flipping it over the line from one side to the other. Let's say that we now have a rectangle, right? And this is where now you start seeing it better. We have a rectangle. We want to figure out how many lines of symmetry this rectangle has. So again, how can we split this for both sides to be the same? We know one way we can split it is down the middle, right? From top to bottom. So now we know that this side is the same as that side, right? So that's one line of symmetry. We know we can also split it this way. Because again, if I were to now reflect the top to the bottom, they're both exactly the same. And so when we're looking at this rectangle, you have to be careful. Because some people would say also split it on a diagonal, right? And so this whole idea of a line of symmetry. If I were to split it down the middle, we can see. If I split it down the middle, both sides are exactly the same, right? If I were to split it horizontally, if we were to split it horizontally, we can see. There's no extra, there's nothing, it's exactly the same, right? If I were to try to cut it on a diagonal, so if I were to try to split it this way, that's where the problem comes up, right? Because now if I try to cut it on a diagonal, and fold it this way, what we see is, if I try to fold it perfectly on a diagonal, it's not a line of symmetry. For one main reason. Just trying to fold it perfectly so you guys actually see it. If I were to fold it from one to another, you know it's not a line of symmetry because it doesn't fold perfectly. We see that there is extra, right? This is over here, this is on this side. Since it's not exactly the same, that's why those diagonals aren't a line of symmetry. So if we're looking at this rectangle, we know only has two lines of symmetry, right? Two lines of symmetry. And then again, that's where a rectangle differs from a square, because a rectangle only has two, right? Because not all the sides are the same. If I were to now look at a square, we know that everything is exactly the same, right? All the sides are exactly the same. So if I'm dealing with a square where I know everything is the same, we know we can split it this way, we can split it across, and since it's a square, we can now split on the diagonal because it's all perfect. We know we can split it this way because it's all perfect. So whereas a rectangle had two lines of symmetry, a square has 1, 2, 3, 4, right? And it's just these lessons, right? A rectangle only has two lines of symmetry because it's only two ways you can split it perfectly. A square has 4 lines of symmetry because a square, it's all exactly equal, it's all congruent. So since it's all congruent, a square you can draw 4 lines of symmetry, right? And that's all reflectional symmetry is, guys. I just want to show you one more example just for you to get the hang of it. And just always remember too, guys, that not everything has lines of symmetry, right? Not everything's always going to be exactly the same, and that's okay. And what I mean by that is if we had something that looked like this, right? If we had something like that, we know there's no way that this has any symmetry. Because regardless of how we split it, if we split it this way, the left is not the same as the right. If we were to split it this way, we know that the bottom is not the same as the top. If we were to split it this way, we know that this is shorter than this. There's no symmetry here, right? So don't always think that everything has a line of symmetry. It doesn't. Not everything has symmetry, right? No symmetry. And it's just getting to that. I just want to show you one more, just so you guys actually get the hang of it. If I were to actually draw something that looked like this, okay? Draw this one purposely longer too, right? Draw something like that. If I had this, and we're going to make the assumption, because again, my drawing is terrible sometimes, we are going to make, when we make it actually longer, so it does look better, make it longer here, just so it actually matches up. So what we know, top matches with the bottom, the right matches up with this, right? So if we were going to show this, we know that this would have one line of symmetry down the middle, because if we were to fold it this way, it would be the same. It has another line of symmetry going across. If we were to fold the top across to the bottom, the top is the same as the bottom, right? Everything matches. So looking at this, we know it has two lines of symmetry. Two lines. And that's all symmetry is, guys. Whenever you actually split it, whether you flip it or what we're going to do the next lesson, turn it with a rotation, it's always going to be exactly the same on both sides. That's why a human face, most of the time, it has one line of symmetry down the middle, because the left side of the face is the same as the right side of the face, right? If you have any questions about symmetry, guys, let me know. Take care.